Well, good afternoon, everyone. Welcome to the second in our series of the ATSE Agricultural and Food Forum talks focusing on climate change and its impact on agricultural systems. My name is Joanne Daly, and in a moment I'll be introducing Professor Snow Barlow, who will actually host this meeting today. So my role is to do the housekeeping, but I'd really like to start with acknowledgement of country. And so as we gather for this meeting today from different places around Australia, I'd like to first acknowledge the traditional custodians of the lands on which we meet. Now, I'm in Canberra, so I'm on the lands of the Ngunnawal people, and I want to pay my respects to their elders, past and present, and to any of Aboriginal and Torres Strait Islander people who are joining us online today. And as we share and discuss our knowledge and practices, we also want to acknowledge the deep knowledge forever embedded in the custodianship of this country. Now, just a couple of housekeeping issues. Firstly, I just wanted to note that these presentations are being recorded. And secondly, you'll notice that you're all on mute and none of you can see each other. You can, however, put questions in the question and answer section and the chat section, but only the panelists can see those questions. At the end of the talk today, Snow Barlow and I will actually take turns to ask your questions on your behalf. If at the end of the talk, if at the end of 1 o'clock, there is still a significant number of questions outstanding, it is possible for us to take a note of those questions and for the speakers to respond to them offline. So with that, I'd like to pass over to Snow Barlow, Professor Snow Barlow, Emeritus Professor at University of Melbourne. Thank you, Snow.
Thank you, Joanne, and welcome to all of you who have joined in this webinar today. The webinar, as you know, is on food, carbon neutrality in food, whether it's myth or whether it's reality. And you're all aware that every state, government and territory in Australia has adopted carbon neutrality by 2050 target for their area. Secondly, the National Farmers Federation has adopted a target of carbon neutrality by 2050 as an aspiration for Australian farming. Today, we have two very distinguished and authoritative speakers. Firstly, we have Dr. Michelle Allen. Michelle Allen is intimately involved in the innovation directions of the Australian agricultural and food industries. She is currently chair of Wine Australia and also Apple and Pear Australia and the Chancellor of Charles Sturt University. She's also a non-executive director of CSIRO and a number of CRCs and other agribusiness areas, mainly to do with food. Michelle, though, was also formerly chair of Meat and Livestock Australia and was instrumental at that stage of introducing the aspirational target of carbon neutrality for Meat and Livestock Australia by 2030. And as most of you know, Australia's agricultural emissions are due to ruminant methane, which Rich will tell you in greater detail. And that was a significant move by Australian agriculture. So I've asked Michelle today to address you on what are the drivers for Australia's food systems to achieve carbon neutrality. And then I will introduce Richard Eckert, who will talk about the sort of technological pathways of how that may be possible. So I'd like to now ask Michelle to address you on those issues.
Thank you, Snow. And thank you to the Academy for asking me to share with you the journey that MLA and indeed the wine industry are on. So my presentation will cover the announcement in 2017 by Meat and Livestock Australia of the red meat industry's carbon neutral target, and I'll briefly cover the industry position of wine. For those who don't know, Meat and Livestock Australia is about fostering the long-term prosperity of the red meat and livestock industry by investing in research and marketing activities. Through its subsidiary companies, it also accelerates innovation across the value chain, delivering industry's integrity and on-farm assurance programs. I thought I'd give you the size of the industry to give you a view of how we are positioned globally and locally. The industry, the meat and livestock industry, turns over $75 billion in Australia, which is about 2% of Australia's turnover. It exports $16.3 billion worth of red meat. It employs 434,000 people. The cattle herd size is approximately 26 million. The sheep flock is around 67 million. And I'd like to tell you that 80% of the meat we produce is exported. The operating environment in Australia is a small proportion of the world's cattle and sheep inventory. It's about 2% of the global herd and 6% of the global flock. However, meat consumption is increasing. Over the last 20 years, a total consumption of meat's been steadily increasing at an average annual rate of 1% for beef, 2% for sheep meat, 2% for pork, and 4% for poultry. Australia is a key exporter in global red meat markets. And in 2019, it was the second largest beef exporter after Brazil. It's the world's largest sheep meat exporter, and we're also the world's largest goat meat exporter. We also export 1.3 million live cattle and 1.1 million live sheep. And interestingly enough, Australia's per capita beef and sheep meat consumption continues to be the largest in the world, 25 kilos per head in 2019, compared with a global average of 14.6 kilos of cattle. And in sheep meat, we eat 6.8 kilos compared to the rest of the world that eats 1.3 kilos. So that gives you the size and the scope of our industry. So given that, on the 22nd of November in 2017, the headline in Beef Central was, red meat industry can be carbon neutral by 2030. And this is because the consumer was telling us in our international markets that the product's environmental sustainability and carbon footprint was an issue for them. We also needed to be ahead of competitors, giving consumers even more confidence in the quality, integrity of the Australian red meat industry by turning environmental criticism on its head. So while the industry commitment was made by Meat and Livestock, we also knew that the right policy setting, new investment in research, and the Australian red meat industry would be carbon neutral by 2030. We could be the first nation to be carbon neutral. To this end, MLA initiated a project with CSIRO based on both consumer and customer needs. The project identified several series of innovation and farm management options, including the expanded use of legumes and dung beetles in pastures, savanna fire management in Northern Australia, feed supplements, vegetation management, and even genetic selection and potentially a vaccine to reduce the methane produced in the rumen. The dividends for the industry we could see was increased productivity, additional farm income from carbon mitigation projects, contribution to the government's target emissions, and a stronger assurance for consumers of our integrity and naturally produced red meat. So consumers were sending very strong signals. And for Australia, the high-value international markets were also telling us emissions from livestock was an issue. We also were facing competition in the red meat industry from the investment from global companies and billionaires in the production of cultured and synthetic beef, sheep, and lamb. And that was based on having a zero environmental footprint and welfare. So MLA believed that the industry could achieve this target, and it commissioned CSIRO to develop a number of projects for us. The first one was collaboration with the Australian Department of Environment and Energy to establish a 2005 industry baseline in line with the federal government emissions baseline. It established contributions from the beef, sheep raising, feedlotting and processing sector to give us an industry greenhouse gas emission. It assumed that we had herd numbers of 28 million cattle and 70 million sheep. It explored options for reducing greenhouse gas emissions from animals, processing and carbon capture for trees and soil, and then an ability to quantify their impacts. We identified pathways based on various combinations of these practices to gain carbon neutrality in 2030. And we determined what research, development and adoption is needed for the industry to achieve these targets. From the analysis conducted so far, the industry is well on the way to meeting its customer, consumer and competitive needs. So if I move to the wine industry is a different beast altogether, pardon the pun. The total vineyard area for Australia is around 146,000 hectares. The total wine grape crush was about 1.52 million litres last year. And we exported, before China, 729 million litres of that wine at a value of about 2.8 billion. There are estimates that there are 2,361 wineries and 6,251 grape growers, implying 163,000 people. So the wine industry had a different position to the red meat industry. It wasn't a focus for the government. But in 2019, the industry announced a carbon neutral target of 2050 aligned with the NFF. It also adopted a sustainability program that was driven by both marketing, markets, consumers, and profitability as we compete on a global basis. The carbon neutral targets were part of a Sustainable Wine Growing Australia program. And this program covers grape growers and winemakers, demonstrating continuous improvement around their sustainability in the vineyard and winery through environmental, social, and economic aspects of the business. So it wasn't a specific target for the industry, it was part of sustainable winemaking. So this program is now being supported by the wine industry, and we've adopted global best practice and we've aligned with the United Nations Sustainability Development Goals. And we're progressing toward monitoring all these annually. The project was launched in 2019, and whilst it's a relatively young program, it's drawn from its predecessor programs, which were Entwine Australia and Sustainable Australian Grape Growing. The grape and winemaking industry decided to take a holistic view in terms of how it could approach its carbon neutral requirements. It focuses on land and soil, it focuses on water, people and business, biodiversity, energy, and waste. So it has a collective view on all of these aspects of sustainability, including its carbon neutrality. However, on a final note, if I conducted a life cycle assessment on a bottle of wine that you may or may not be consuming, I suspect that the bottle will be the biggest contributor to our carbon footprint because of the production of electricity in Australia from coal-fired power stations. So thank you very much again to the Academy and Snow, and I'll hand back to Snow.
Thank you, Michelle. That was a wonderful introduction, and from someone who is literally sitting in the box seat. And it's wonderful to see Australian industries agricultural industries trying to be on the front foot in what is a global movement that will ultimately influence the markets for our export products. So without any further ado, I'd like to introduce Professor Richard Eckert. Richard has been working in climate change in agriculture, both adaptation and mitigation, for more than 20 years. He currently is an advisor to a number of governments, including Australia, New Zealand, UK, the EU, and of course, the UNESCO. And further, Richard is a leader of the global, within the Global Research Alliance on agricultural greenhouse gases and their mitigation. And finally, Richard, a couple of weeks ago, was named as one of the 1,000 most influential climate change scientists in the world by Reuters as part, as really recognition for his work in climate change in relation to agriculture. So Richard, over to you.
Thank you, Snow, and thank you for the introduction. Presuming you can see the slides and hear me. Great. Well, I'll assume that. So my job is to take what Michelle has presented and then go on to, well, what are the technological options that are coming through? What are the options for us to move in this direction? And so I'll deal with areas of methane. I'll deal with areas of nitrous oxide, probably not so much carbon dioxide because those are very obvious, but deal with the sequestration aspects as well. And so you can see this is the profile of where emissions in agriculture would come from. Methane largely from ruminants, and if you look at those two pie charts there, you can see how dominated a emissions profile of a livestock property would be by methane as a greenhouse gas. Nitrous oxide from any form of nitrogen in our agricultural systems. Energy from the usual sources, carbon dioxide from lime application, urea, fertilizers. But let's not forget the ability of the landscape, of the land sector to store carbon as well, and I'll deal with that. So when we break it down and we start looking at where these emissions come from, you can see where some of the debate comes from around the differences between industries. So you've got a typical dairy profile in the top left, you've got a rangeland beef system down the bottom middle, and a grain pulse system on the right. And what I've presented there is a typical emissions per unit of product, so the emissions intensity of those. So you can see a dairy could be quite high in terms of emissions per kilogram of milk solid, or a beef product in terms of per kilogram of live weight. And then a far smaller emissions profile from, say, a cropping system, because it's not dealing with this large methane. So unashamedly, the talk that I'm giving will focus on methane first, because it's, as Michelle said, it's one of the big issues we've got to deal with. Now, we have seen some movement in this direction, and if you just do a quick web search, you'll come up with both examples that Michelle presented. Livestock, there's at least 3 companies marketing carbon neutral livestock production, and at least 3 wineries promoting carbon neutrality. Now, to be fair, it's a lot more challenging, obviously, as a livestock producer to be carbon neutral than it would be for a wine operation that's not dealing with that large methane profile. If the largest emission is the CO2 embedded in bottle manufacture, a lot more achievable in the wine industry. But nonetheless, both should be done. Now, in all these examples, the majority of the carbon neutrality is achieved through carbon offsets rather than action directly on the emissions. But we have published at least 2 case studies of carbon neutral livestock production. Here's one where we started with a low stock wool producing farm at ATSE, John Ives, and there was significant land restoration in this. So a lot of natural regeneration of trees, a lot of gully erosion that was fixed. So a lot of carbon sequestration you can see in the graph on the right, with a very small greenhouse gas emissions below the horizontal line, which you can see in this particular case, very easy at a low stock property to be carbon neutral or carbon positive in the case here. We then went across to Jigsaw Farms, Mark Whitten's farm, looking for a high stocked example. Mark had planted more than 20% of the farm down to trees for a number of reasons. And again, you can see the emissions profile, but with a far larger methane tracking below the line there. So these are largely achieved through offsets. if we then start looking at what are the options and the challenges for reducing methane from livestock production, we've got to remember that this is a microbial process. Both nitrous oxide in soils and methane, they're microbial processes. This is something that evolved about 50 million years ago, the rumen evolved. And we're aiming to change this whole ecology in 20 to 30 years worth of research. So adaptation of that rumen dynamic environment is a major challenge. Just to give you some idea of what we're dealing with, there's a profile of the microbes that are present in the rumen. And you can see the microbes producing methane are only about 3% of the total, but nonetheless quite important. So adaptation is a very dynamic process, and there's a number of mitigation options we've explored over the years where the rumen just simply adapts within 3 months and we're back to where we started. Now, methane is a form of anaerobic respiration where the microbes are using surplus hydrogen and CO2 that are left over from volatile fatty acid formation and disposing it in the most energetically efficient way, which seems obtuse, but it is, as methane. Now, what's important is we've concluded producing methane is not essential for the ruminant. So we can eliminate methane and continue with profitable livestock production. And I think that's the key point. But the key issue is this graph here where we've shown most bovines in Australia, for example, their methane is a function of dry matter intake. And that graph integrates digestibility with dry matter intake and shows the relationship to methane. So you've got dairy cattle on the top right of that equation where they're highly digestible foragers, they're eating lots, they're producing a lot of milk, they produce more methane. Down the bottom left, you've got rangeland beef cattle, low digestibility diet, eating less, but producing less methane as a result. The key issue for our mitigation is how do we change the slope of that line? And so there are options that have emerged over the past 20 years that are around better management of animals. So one of the projects I'm involved in is with the International Livestock Research Institute is just quantifying if we treated all the sheep in East Africa for worms, how much methane reduction can we get? And it's quite a significant number just by improving the efficiency of digestion in animal health. Improving digestibility, higher digestible forages will produce more propionate and reduce methane. Michelle touched on legumes. Really important that we as an agricultural industry rediscover legumes. I think we've forgotten them. These are legumes that can improve the protein quality, the nutrition of animals, but they can also improve by having secondary compounds in them. They can introduce ways of the tannin reducing methane as well. So very important that we re-explore that under a carbon neutral agriculture. Some native shrubs have been shown to reduce methane as well. And we take some of that logic and we say, well, we know tannins in legumes reduce methane. We also found oils in agricultural byproducts can reduce methane. And then we went looking for a natural waste product from industry, from agriculture, that had both of those present. And we found grapemark, which has got tannin in the skins and oil in the seeds, and was a waste product from the industry. And it gave us a complementary effect, not the least of which now grapemark is fully bought out by the livestock industries instead of being a waste product. So that's a good news story. Michelle touched on breeding, and breeding is one of the options, not only breeding animals that produce less methane, but breeding plants that have compounds in them that help animals reduce methane. It is an incremental change, and that's one of the struggles with producing an offset method around breeding, is that you only get about a 1% gain per year, but cumulatively over a decade, you will get a reduction in methane. On the right now, I'm giving you the more prospective options that are coming through in research to give us hope for the future. The vaccine program, big challenge. It's been in research for more than 20 years, but we are about to see something come through in the next short while, which would be a solution for the more extensive grazing industries. We've heard a lot about some of the inhibitors on the market, the Asparagopsis seaweed, and a product called 3-NOP. And these are the products that actually have shown us that we can reduce methane by more than 80% now through these various inhibitors. Now, there is some due diligence still to go with some of these products to make sure we're not creating more of a problem through their production chain. And so we need to make sure that we're doing that. But they have given us hope that there's a future. And just for interest's sake, people have been thinking outside the square. What happens once the methane's left the animal? And there's a commercial company called Zelp, as an example, where they've got this 4 kilogram device you hang around an animal's neck and it oxidizes methane as the animal breathes out. So you can see solutions starting to come through. That wasn't around 2 years ago. So solutions, innovations are starting to come through. I'm almost of the opinion that this 4 kilogram device is this symbol hanging around an animal's neck telling us long-term we need a better solution, but it might be an interim solution. But where we need to land ultimately is the prospective research around early life programming. And this is some early research in that graph on the top right, which shows that you can actually train animals, you can wean animals onto a low methane profile, and it perpetuates. So the gray area is where they used a product, one of those inhibitors, 3-NOP, to train animals to be low methane. And then the right-hand side of that graph, the clear area, is where those animals remained lower methane producing for the next 12 months. And this is actually where the research has to eventually land: low-cost, perpetual, repeatable solutions for the more extensive industries and the developing world. Now, what are the challenges? Well, most of the options I've shown you are probably more suited to the intensive agricultural systems, not the extensive systems or the subsistence systems or the communal grazing systems of Africa and South America. And this is where most of the livestock are currently and will be in the future. And so we need solutions for all of agriculture, not just the intensive industries. Obviously, inhibitors are something that is very easy for the dairy industry or the feedlot industry to feed to animals on a daily basis, but become prohibitive in the extensive grazing industries or become prohibitive in the developing world. So we need those solutions to extend. And this is where I think this early life programming has potential to send a signal saying, we need these solutions that are repeatable, inheritable in the more extensive and lower priced industries. So that's the challenge. Moving on to nitrous oxide very briefly, again, a microbially mediated process, mainly in anaerobic soils. And again, this is something where these microbes have settled down to a steady state over somewhere between 2 billion and 50 million years ago. These processes emerged. We aim to change that in a 20 or 30-year time horizon. So it is a challenge, and adaptation becomes a challenge. A small process by which nitrous oxide is evolved in soils is the first step in that graph on the right, where in warmer aerobic soils, a process of nitrification releases nitrous oxide. It's a minor pathway, but for the extensive dryland grains industry, where most of the soils are aerobic, it's the most significant source of nitrous oxide from those industries. Having said that, most of our nitrous oxide in our more nitrogen-dependent agricultural systems comes from denitrification in warm, waterlogged, or anaerobic or compacted soils. And so that's the process we really need to deal with. So the options come back to better use of nitrogen fertilizer, more judicious use of nitrogen fertilizer. You can see in those two graphs there, the diminishing returns curve in terms of yield. As you increase nitrogen fertilizer use, you get diminishing returns. And what happens when you exceed that maximum yield point is the graph on the right, which is the nitrous oxide loss to the environment. So clearly, rate, source, timing, placement of fertilizer inputs becomes really important. We're starting to see inhibitor products or slow release nitrogen compounds come through. But I would say this is where legumes come in again, a more benign, slow release form of nitrogen into our agricultural systems. Rotations of cropping with legumes, with pulse crops, rotations into pastures that have legumes in them becomes important for the future. But let's not forget a significant source of nitrous oxide. Somewhere between 70 and 95% of livestock urine is straight liquid urea. And so feeding animals on a more balanced diet that has an energy to protein ratio that is more in balance is really critical for the future to reduce animal urine nitrous oxide losses. And then because nitrous oxide is mainly in compacted anaerobic soils, we need to look after soil saturation, drainage, reducing compaction, reducing soil disturbance, which is also good for maintaining good organic matter in our soils as a way forward. But if we look at the challenges for nitrous oxide, nitrogen is essential as a nutrient into maintaining crop and pasture production. We need it, but it is also our most leaky element in the soil. You can see figures there of the typical nitrogen in a grazing system that never completes the cycle. And if we start to move into a world of more closed loop nutrient cycles, of circularity in agriculture, we need to do something about the nitrogen cycle and its inefficiency. And I think we can improve on that. So the future should focus on these more slower release forms of nitrogen, nitrification inhibitor compounds, slow release coatings. Even though these will help with the more high end of agriculture, they are expensive of most of the world's land managers, and we need to keep that in mind. And this is again where legumes come in. Michelle mentioned that as one of the solutions. Again, not only for methane reduction, but they become important as part of a less reliance on fossil fuel-based fertilizers, a slower release form of nitrogen, and also more applicable to the developing world as well. And remembering that we're moving into a world that is looking more at closed-loop nutrient management, circularity in our food systems, and remembering that actually some of these subsistence agriculture systems are far more circular than some of our more linear production systems where we buy fertilizer from an industry and then have a linear transfer of that nutrient via agriculture down to our cities and out to Werribee in the case of Melbourne. We need to think more about the circularity in our food systems. I thought I'd finish off just with a few thoughts on sequestration. Starting off with soil organic matter versus soil carbon. We've got this focus at the moment on soil carbon as one of the solutions, when in actual fact, soil organic matter is much more for our future, much better for our future than just focusing on soil carbon. Building soil organic matter is very important and good for healthy future productive agriculture, for adaptation to climate change. And a lot of our analyses would show the co-benefits of building soil organic matter are far bigger than the carbon income you might get from soil carbon alone. And so we might have focused on the wrong target. And if you take this graphic that Jeff Baldock used to use, there are so many co-benefits from building high soil organic matter that we shouldn't just focus on soil carbon as the only outcome. The future of agriculture depends on our healthy soils, and that should be our focus. We also forget the law of diminishing returns in a lot of our enthusiasm for soil carbon, that the changes take a long time to come about from a change in management. And we forget the diminishing returns. There's a lot of groups around promoting that you can build soil carbon in perpetuity, and there's nothing in the science that would suggest you can do that. Diminishing returns is definite. It will reach a new steady state. Plus, we forget that the management changes you implement to build soil organic matter, they need to be maintained in perpetuity as well, if you are to maintain the change in soil organic carbon as a result. And so if you revert those management practices, you will reach back to the steady state you started at. So let's not forget some of those basic principles of soil carbon. I think we also need to rethink trees on farm for the same reason. We've been focused on trying to get farmers to plant trees for carbon credits when they struggle to match the value of the land. If you compare dairy income from that same area of land or wool income, it never matches the carbon credit income. But if you start looking at the co-benefits and valuing those, I've just got a few listed on the screen here. The co-benefits of trees on agricultural land are orders of magnitude more benefit in terms of animal welfare, future heat stress amelioration, even capital appreciation of the land, where a recent study from the University of Western Australia showed with 20% tree coverage, a property could achieve somewhere between 4 to 8% price premium on resale. A lot of that is not captured in our focus on carbon credits. And so how do we design trees on our agricultural land for these multiple objectives and not just focusing on carbon? So what are the challenges? I think we can reduce methane and nitrous oxide by about 80% right now with technology. In the next 20 years, we might do better, but it's still not 100%. There will still be a need for offsets in the land sector to achieve carbon neutrality in their own right. And that's what the CN30 report to MLA showed us as well. The important message here is the land sector needs to stop trading sequestration's offsets outside of their sector and selling them on internationally or selling them off to other entities, because the land sector will need their own offsets to achieve their own carbon neutrality. There's also an early warning in the science literature coming through challenging the notion of net zero and saying it needs to be absolute zero, and the sequestration takes us below zero to remove CO2 out of the atmosphere. And so the challenge is really around mainly that the concept of net zero, we can just offset our emissions, sends the wrong signal that we can continue business as usual and we'll just offset our emissions. And that's not where we need to land up. We need to actually aim for zero emissions and then sequestration below that. We're also facing a fairly significant issue in the agricultural industries of a misinformation and pseudoscience going around soil carbon. And this needs to be addressed fairly quickly because we have a lot of non-peer-reviewed good narratives around soil carbon potential, creating unrealistic expectations with farmers that ignore the law of diminishing returns. And so I think the science community has a role to set the record straight on what is achievable with soil carbon, not the least of which climate change itself will challenge our ability to maintain current soil carbon stocks, let alone seeing soil carbon as the way we're going to solve our emissions problem. It doesn't take much sophisticated modeling to say if growing season rainfall is decreasing, you can't increase soil carbon. So just to finish off, there's a significant global effort going on. I'm involved in a number of programs in the EU, in North America, New Zealand. Collaboration is the key. We don't have to do all the research here. We just have to tie in with the global effort that's going on. Our research has moved from the days when we could only reduce methane and nitrous oxide by 20% to now where 80% potential has been shown and clearly demonstrated. Agriculture will need offsets to truly become carbon neutral in the short term. But remember that this is only a short-term solution for the future. We need to actually look at absolute zero. And let's keep in mind in our research that the options that we're looking at the moment are limited for the extensive grazing industries, the subsistence agriculture communities, and communal grazing systems. We really need solutions for the majority of the world's farmers, not just the intensive livestock industries as we currently have. So Snow, thank you. That's the technological challenges.
Thanks very much, Richard. That was terrific. And thanks very much also to Michelle. Now we've got the questions and answers open. I've also got something coming through the chat, but let me first ask Michelle a question, if I may. Michelle, we've seen governments have been very reluctant to engage in this debate and actually want to push back, but we've seen industry very engaged and very proactive, and you talked about that in the wine and the meat industry. I guess my question is, to what extent is government policy settings important to enable the industry to achieve its goals?
I think that part of our discussions in the red meat industry and our sustainability is around the government policy settings. And I note that the Cleaner Technology Regulator has made a call for submissions around cool soils. And I acknowledge Richard's discussion about carbon, but the government settings are really important for us, especially in the wine industry, as I said. Manufacturing bottles for the wine industry is highly energy intensive. The mass is around 850 C. So you can imagine if there's only gas or electricity available, that can be quite a dirty process. So for us, it's very important. Department of Ag and Water have been very supportive of the red meat industry and the wine industry, and their settings are around enabling funding for collecting carbon emissions, sequestration, and other issues that farmers have. So for us, it's very important.
Thanks, Michelle, and thanks, Rich. I have a question here from initially from Wallace Cowling, and it's regarding the soil carbon. And he asks, Rich, is that long-term cropping experiment at Rothamsted showing diminishing returns to soil carbon content, interesting lower than expected sequestration in soil. Capturing soil C is not the solution. That's from Wallace Cowling, Rich.
Yeah, look, I showed the long-term experiment that Rothamsted because it is the longest experiment in the world, capturing all forms of carbon in their analysis, showing that diminishing returns. Yes, you know, most of the increase in soil carbon when they came out of cultivation into a permanent pasture, they showed this trend where soil carbon did increase rapidly initially in the first 25 to 50 years, then showed diminishing returns and a long tail. So that experiment's been running for 300 years, and not much in the last, you know, in the recent period. It's pretty flat now, which means things do reach a steady state. I think what that teaches us is we can destroy soil carbon pretty quickly by putting cultivation through our agricultural soils. But it takes a long time to restore it back to a new steady state. I think the point about soil carbon is there's been a real focus on promoting it to farmers that this is something you can get that'll increase in perpetuity. And so what I'm showing in that is that's not the case. It will just reach a new steady state that reflects your new management, and it'll probably take 25 to 50 years to get there, but it will level out. So let's not expect that this is going to be a permanent solution to offset our greenhouse gas emissions. It's only a temporary solution. Plus, the point I made about growing season rainfall, you know, it's not a sophisticated equation to say rainfall determines plant growth determines root growth, and root growth determines soil carbon. If you reduce growing season rainfall, you reduce plant growth, soil carbon is the result, lower soil carbon.
Sorry, thanks. Thanks, Richard. Richard, we have another question for you. What is the role of better fertilizer management on nitrous emissions, and what needs to be done to achieve these reductions, and what role does precision ag play in achieving this?
Yeah, look, certainly in the industries where nitrogen fertilizer is significant, some industries use large amounts of nitrogen fertilizer. Just cutting back the rate of nitrogen fertilizer to match plant demand more accurately, I think is the first step. One of the problems we've got is nitrogen fertilizer is relatively cheap. And so we find a lot of farmers over apply just as an insurance policy rather than actually applying exactly what they need. The greater awareness of the loss function, which is exponential once you get to meeting the plant's demand, shows how important it is to cut that rate back. I do think we need to be more judicious in some industries where we've got too much nitrogen fertilizer being applied. But if you take the extensive grains industry, you know, we probably in Australia put less nitrogen on our extensive wheat fields than most other countries in the world, just because rainfall is the determinant. And so there's no point in wasting nitrogen. So, you know, it's tricky. You go into an extensive grains industry where your emission factor is less than 1% of the nitrogen fertilizer gets lost as nitrous oxide. It's pretty tricky to make major changes to that industry. But I do think we'll see more benign sources of nitrogen being used in future. Certainly, and precision agriculture, I think, plays a role because you are placing the nutrient where you need it, when you need it, for most effective uptake. And I think that's really important.
Thank you, Rich. Michelle, perhaps a question that you didn't have time to deal with, but you know, as an agribusiness person and someone who sits across a lot of industries, do you see potential for Australia's export industries and indeed local industries as well, if we can achieve carbon neutrality, as perhaps capturing some premiums in the global food markets?
It's a good question, and at the moment, probably the EU is where you're going to capture the greatest margin because they're looking at all of these, especially from a wine perspective and a red meat perspective. Red meat going into the EU already gets a premium because of their requirements on animals in feedlots and grass-fed animals. So the answer is yes to certain markets. To other markets, I suspect not. So for instance, I doubt whether you will get a premium into China. At the moment, as you know, there's no wine going into China anyway. But the wine purchases in China are based on labels rather than anything else. And so a Penfolds Grange is going to get a huge purchase irrespective of anything, would be my suspicions. Now, Canada, a different set of circumstances again, and the US, given President Biden's view on carbon and global warming, I suspect that over time you will see for our sheep meat going into that country, if we can achieve carbon neutrality and we can measure it, you may get a premium in that market.
Thank you.
Okay, thanks. A question, I guess, back to Richard. Richard, we've had a number of questions associated with actually either soil additives or changing the diet of rangeland animals. So, for example, what's the potential of alley farming of edible native shrubs such as saltbush, or what about biochar? You haven't talked about that. What's the potential for paralysis of carbon and long-term biologically stable storage in soil? And there's also a question about the use of seaweed as a cheap solution for subsistence farmers elsewhere. Is there an interest in growing a seaweed industry here in Australia and possibly exporting that elsewhere?
I'll try and wrap those up into an answer. Things like alley farming, I think we've got to think about what are those shrubs and their direct effect on methane. But if you think more holistically, you think about things like Leucaena in Northern Australia, where they do plant it in rows, and Leucaena has been shown to reduce methane. But we've also published a study that showed Leucaena not only reduces methane, but it addresses a soil nitrogen deficit in that system, where the Rhodes grass, companion grass, starts growing better. You get better animal production overall, and you get better soil organic matter as a result, because this Rhodes grass has now got a better root system because you've addressed the nitrogen deficiency. So I think we need to think about those co-benefit type approaches. Saltbush, probably not as much because it's not a legume, it's not providing that, and it doesn't have a direct impact on methane. But, you know, Desmanthus, Leucaena, Sulla in Southern Australia, I think there are options we can look at that are those legume row crops. On biochar, look, there's been a lot around biochar, and I'd probably say biochar is not biochar. It actually depends where it comes from and what the source material is and how much you char it. There's a perennial problem here. If you char biochar completely, it's charcoal and therefore is a permanent store of carbon, but it has very little land value because you've blown off all the nutrients. If you don't char it properly, well, it's still an organic form of nitrogen and it won't be a permanent form of carbon, but it might have some agronomic value. So you need to be aware of biochar, where it comes from. I do think that sometimes the work that has shown a reduction in nitrous oxide from applying biochar is the same as why we use activated charcoal to reduce toxins. We're basically absorbing nitrogen. We are mobilizing the nitrogen in that system. So we've got to be careful about the solutions we use. And I'd go into the seaweed as well. And look, I'm a fan of the seaweed as a way of reducing methane. It told us we can achieve a lot. But you've got to remember the active ingredient in the seaweed is a very powerful chemical, bromochloromethane or bromoform. And there's still some due diligence we need to do in the research to make sure that we're not introducing a chemical that will have some greater impact long-term on ozone than the reduction in methane. Now, I'm not saying that's a problem. It's just, it's early days in the research. We need to actually show that we're not introducing iodine into the food chain, that we're not introducing a new chemical that is going to create a problem later on, and where we will grow the seaweed and all that. So there's a lot of logistical questions there. Having said that, I repeat, you know, great fan of the technology, because it has great potential. It's shown us we can break this 20% barrier with methane. We can get to the 80% reductions in methane.
Richard, another question for you, and this is just because Australia and much of the global livestock area actually reaches, stretches across subtropical and tropical areas. So there's a question here is, what is the relative potentials of soil organic carbon, tree carbon sequestration and greenhouse gas reductions in the tropics compared with the temperate zones, which we tend to concentrate on in our more intensive agricultural areas?
Yeah, it's a very complex question in that you will find, say, just take Australia. In Northern Australia, there's less of a clear rainfall signal under climate change. So if we had to predict what's going to happen to soil organic matter under Northern Australian systems, we really don't know that much at this stage. What we can say in Southern Australia, in the sort of Mediterranean or winter rainfall regions, there's a clear reduction in growing season rainfall, which has a negative impact on soil carbon. So you could almost say carbon sequestration in northern grassland soils might actually be better than in Southern Australia because of the change in rainfall. Obviously, rainfall in terms of tree growth is a major determinant as well. If you've got tropical conditions in the north, say in Central Africa, the potential is huge. And there's a great Nature paper that showed that we've got a global greening going on because of higher CO2, enhancing tropical forest growth. So the potential for trees to grow in the tropics where there's good temperatures and good rainfall is pretty high, probably more so than the temperate zones. When it comes to greenhouse gas emissions reduction, it probably is more around the technologies as they emerge. So where we've got technologies, the temperate zones tend to have more confinement systems where we've got more access to animals, like the dairy industry in Australia, for example, or around the world, really. Whereas a lot of the rangeland systems of the world are in the tropics where you might have less opportunity to intervene, which is my pitch for why we need more technology there.
Michelle, a question for you. One of the concerns I have around the pitch of trying to reduce the consumption of meat because of its impact potentially of greenhouse gas emissions is that people ignore the nutrient argument, nutritional value of meat, particularly in the developing countries where it is a significant source of protein for these people. How do we sort of deal with that issue, address that issue? Because it's an argument that's lost in the discussion around the greenhouse gas emission impacts.
It's a good question, Joanne, because when I was chair of MLA, we brought Manny Noakes, Professor Manny Noakes, onto the board specifically for that skill set to actually help people understand the nutrients that they are missing out on by no meat consumption or the issues around no meat consumption. The industry has to be very careful about how it presents that data. And so some work was done by CSIRO many years ago around the nutrients that you do get from a healthy diet. It also informs the NH and MRC guidelines on red meat consumption. So it's difficult for the industry to do it. It's actually beholden to the nutritional society and the people who are doing the research to represent to consumers why you might need red meat in your diet. Having said that, the red meat industry is also aware of the increasing focus of increasing legume proteins for exactly the same reason. And there's a lot of research being done on how that might happen. So I think it's actually up to the people who are on this line today to begin the conversation about why there is, in most situations, a need for meat consumption in terms of it's not just the protein, it's all of the other minerals and nutrients that comes from an animal protein source that you may or may not get from a plant protein source.
Thank you.
Could I perhaps add to that? I think there's a global picture to think about as well. I use figures of I think it's 16% of the world's population earn over $20 or $20 a day. And if you take that as a nominal point at which you have some determination over your diet, the majority of the world's population actually don't even get a choice. The actual concept of diet choice making a global change to greenhouse gas emissions is really a very privileged worldview to say diet choice will make a difference, because only 16% of the world's population even have that choice. And I think there's a lot of naivety in some of the global analyses that have taken place that have shown if we all stopped eating meat, this is what will happen, because that's just simply not the reality of most of the world.
Mm. And that's what our studies would show in the red meat industry as well.
Rich, another question, back to where we haven't addressed much, is in terms of around soil carbon storage. You did make some rather, sort of strong comments around the pseudoscience around this and what's been prolongated in the media. There's a question about how should we in the science community and indeed in the policy community address this, or whether, will the market sort it out, or does there need to be greater scrutiny of the actual auditing of soil carbon claims?
I think what we're seeing is the market is not sorting it out. The market is sort of, in some ways, enhancing the discussion along sort of alternatives. What it will take is the soil carbon science community to get together and put out a few statements setting the record straight. This is what we can justify from the science. This is the likely change you can get in soil carbon. These are the achievable targets for Australia. And just so that you know, that is currently happening at the moment. There is plans afoot. I'll leave it at that.
I have a question from Michelle, and we're getting quite close to the end. Michelle, in the meat and livestock sector, can producers be carbon neutral and get paid for their carbon sequestration at the same time, either by governments or on a voluntary market? And Richard, you might want to follow up too, because I know you have a view on this too. So Michelle?
That's the position that the industry is taking at the moment, that you can do both, and some of the research that MLA is conducting is actually helping producers to understand what they can do and how it can be measured. Interesting, the CRC for Food Agility is putting together a consortium of the ASX, Data 61, and possibly CSU, to look at pitching around measuring carbon in soils outside of soil testing using blockchain from Data 61, and also bringing Department of Ag and Water in to recognise how this can be done and how producers could get paid for this and how the exchanges might work. So they may not be able to trade at the moment, but the stars are aligning, and I would say that they will be able to do both very soon.
Thank you. Thank you. Richard, do you have a comment around this?
Yeah, look, Michael's touched on an interesting issue here, and that is, can you sell your offsets out of your business and still claim to be carbon neutral? That's possible. There might come a day in the near future where that's not possible. And I suspect we will start differentiating between sequestration credits and emissions avoidance credits on that basis. Because if there's a date by which your business needs to be carbon neutral and you've sold all your sequestration credits, well, you can't use them anymore. They're gone. Someone else owns them. Whereas emission reduction credits, so emissions avoidance credits, you can sell them quite happily until the day you need to be carbon neutral. Then you apply your Lucina credits or whatever, and that'll be against your business. The point I'd like to make here is we should be careful. It's not necessarily in the national interest for us to be selling sequestration credits outside of Australia. It doesn't help the national interest.
Thank you very much. Sorry, Snow, we're actually out of time, I think.
Yes, can you thank our speakers, please?
So, yeah, I was just about to. Okay, so on behalf of Snow and myself and the Academy, I'd like to thank Richard Eckert and Michelle Allen for 2 stimulating talks. And I think it really is part of the ongoing debate around soil carbon, organic carbon, and the meat industry, particularly meat and livestock industry. So I would really like to thank both of you for your excellent talks. And we do have a set of questions that haven't all been answered, and so we can get back to those later on. So with that, I draw the seminar to a close. Thank you.
Thank you very much.
Thank you.
Thank you.